Welcome to the calculus class. We start module 4 this session. First topic is parametric equation. What is a parametric equation is? Parametric equation represent curve in different way. So previous lessons we use function to represent some curves. But these lectures we give new way to represent curves. This parametric equation also describe motion and orientation. That's the difference from the function we studied so far. Second is we're gonna sketch parametric curves using a table and determine their direction of motion. That's the huge part of parametric curves. Third is convert from parametric equation to the Gaussian forms or Gaussian form to the parametric equation. Let's get started. Before we start definition of parametric equation, let's have a simple example about parametric equation. So, how can you describe where the car is at any time? T equals 0, we start the car in that position. We're gonna drive the car around the track. So you wanna know t equal to where you are. T equal to, you drive counterclockwise, then you stop there. T equals 4, you're gonna stop another stop sign. Look at this one. T equals 0, you know the exact position. T equals 2, you know the exact position right there. This one represents counterclockwise. T equals 4, car is stopped right there. How gonna describe this trace of driving? That's we're gonna use parametric equation. Parametric equation have parameter t. T gonna be represent time. X is position depending on t. Y also position depending on t. So x, y depending on the time t. T is between the A and B. We call this is parametric equation. So when you have all the point x, y depends on t value, that's correction of x, y we call parametric curve. Parameter t usually represents time. This equation describes how point moves along the path, showing direction and orientation. Let's have first example of parametric equation and sketch the curve. Look at the x depending on t value, y depending on t value, t gonna be start point 0 and point 4. Let's thinking about t is time. T equals 0, x represent position, y represent position. So this one is make a table, guys. You're gonna make a table right here. So t gonna be first column, x position depending on t, y position depending on t, x, y position on the plane. So t equals start point is 0, right? T equals 0, plug in the t equals 0, x value is 0, y value is 1. Your position gonna be 0 and 1. You're gonna plot it 0 and 1 right here. That's gonna be 0 and 1. That's your position. T equals 1. X gonna be t square minus 2. 1 square minus 2 minus 1. Y value is 2. That position gonna be negative 1 and 2. T equals 1. Your position gonna be negative 1 and 2. T equals 2. So x value 2 square minus 2 times 2. That's gonna be 0. Y equals 3. Your position gonna be 0 and 3. So here 0 and 3. T equals 2, 0 and 3. t equals 3, x gonna be 9 minus 6, x value is 3, y value is 4, that's position gonna be 3 and 4. t equals 4, x gonna be 16 minus 8, that's the 8, y equals 5, that's gonna be 8 comma 5, your position is 8 comma 5. That's connected to each point. You have to see this one, guys. Here, start point t equals 0. 1, 2, 3, 4. They represent curve, but each point represents position, t value. So this graph shows t equals 0. That's the we call initial point. T equals 4. That's the terminal point, and the point give the direction of movement. T equals 0 is initial point, t equals 4 is ending point. So we see how object move by the parametric equation. Let's have another example of parametric equation. What curve is represented by following parametric equation? X value is cosine t, y is sine t. Both function depends on t equals 0 and 2 pi. So make a table, t, x, y point, coordinate plan. Let's plot it. t equals 0, cosine is 1, sine equals 0. Your position gonna be 1 and 0. t equals 0, 1 and 0. Here, 1 and 0. That's the initial point, right? t equals pi over 2, cosine pi over 2 is 0, sine pi over 2 is 1, 0 and 1. You're gonna plot t equals 1, 0 and 1. t equals pi, cosine pi is negative 1. Sine pi is 0, position gonna be negative 1 and 0. You're gonna plot t equals pi. Your position is negative 1 and 0. t equals 3 pi over 2. Cosine 3 pi over 2 is 0. Sine 3 pi over 2 is negative 1. 0 and negative 1. t equals 2 pi. t equals 2 pi. Cosine 2 pi is 1. Y equals sine 2 pi is 0. Your position is 1 and 0. That's gonna be terminal point. Let's connect all the point you find. t equals 0 is start point. You're going to t equals pi over 2, t equals pi, t equals 3 pi over 2, go back to 2 pi, end point. Then you see this direction, and he moved this direction. This one is counterclockwise, this object to move. Okay? Counterclockwise. But that curve represents a circle. Let's have another example. What curve is represented by following parametric equation? This time, x gonna be sine t, y gonna be cosine t, t gonna move 0 and 2 pi. So we did exactly same. T value gonna be 0, pi over 2, pi, 3 pi over 2, 2 pi. X, y gonna be, x is sine t, y equals cosine t. We're gonna sketch the curve. T equals 0, 0, 1, right? T equals pi over 2. Sine pi over 2, 1 and 0, 1 and 0. T equals pi over 2. Your position is 1 and 0. T equals pi. Sine pi gonna be 0. Cosine pi is negative 1. 0 and negative 1. That's right there. T equals 3 pi over 2. Sine 3 pi over 2 is negative 1. Cosine is 0. That's gonna be negative 1 and 0. T equals 2 pi. T equals 2 pi. Sine 2 pi is 0. Cosine 2 pi is 1. That's gonna be 0 and 1. So this time t equals 0 is initial point. t equal to pi terminal point, but start here. Then you're gonna move clockwise. Okay? So here, you're gonna move this direction. This looks like a circle, but direction is different. Clockwise, 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 clockwise. Guys, make sense? Previous one is counterclockwise. This one is clockwise, but both parametric equation represent circle. So what is the strength of parametric equation? You can decide which point you want to start, which direction you want to go. Now, we study how to sketch parametric equation depending on t-value. You make a table, then sketch it. Now, this one is parametric equation depending on t. I wanna change this parametric equation to the Gaussian equation or rectangular equation, which meaning is we're gonna write curve y equals something or no parameters, no t value. So how gonna do it? Here is we're gonna eliminate t value. Then we only find x, y variables, okay? So first thing is you're gonna decide which equation you wanna start. Looks like x is t squared minus 2t, that's quadratic. This is degree 1, linear. So I'm going to start y equal t plus 1. That's how I'm going to start it. Because that's much easier to solve t. So t going to be y minus 1. Then t going to be eliminated. So t going to be y minus 1. What you have to do, you're going to substitute into the other equation. That's x. X equal t squared minus 2t. They have t value. You're going to plug in t equal y minus in there. You eliminate t. So x going to be y minus 1 squared minus 2y minus 1. Let's simplify this one. That's going to be y squared minus 2y plus 1. Distribute to negative 2. Negative 2 plus 2y. So you have y squared minus 4y plus 3. We call this one, there is new parameter, right? That's what we call rectangular equation. So, two different equation form. Parametric equation, they have parameter. X, y depends on t. Rectangular equation, though, there is no another parameter, another variable. So only x, y. So we call rectangular equation. Let's practice one more. See, here is x is degree 2 of t. This is degree 1. What you have to do, this is called parametric equation because they have parameter t. So we have eliminating parameter. You have to decide which equation you want to start. I want to start y equal t over 2 because degree 1. So let's solve for t. One equation. Y equal t over 2. So we want to solve for t. You times to both sides. T equal to y. Now, we're going to substitute this t equal to y into the another equation. So x equal, excuse me, t equal to y. So x equal 2y squared minus 4. 2y squared gonna be 4y squared minus 4. We find x equal 4y squared minus 4. That's what we call rectangular equation. Regular form of the equation form we usually see, right? This is a parametric equation depending on time. This is rectangular equation. Let's have another example for parametric equation to convert into the rectangular equation. This one is x equal cosine t, y equals sine t. We have this parametric equation, right? Then sketch the curve. Another one is x equals sine t, y equals cosine t. This one is not easy. Eliminate t or eliminate solve for t here. So what are you going to do when you have cosine and sine? We use Pythagorean identity. Guys, remember that Pythagorean identity? That's gonna be cosine squared t plus sine squared t gonna be 1. So I want to using this identity to find the rectangular equation. So x gonna be cosine squared t plus sine squared t 1. Cosine t gonna be x, sine t gonna be y. So we have x squared plus y squared 1. This represents a circle. Center is 0 and 0. Radius is 1. Let's check another parametric equation. We sketch it. This one is counterclockwise. This is clockwise circle, right? So same thing. Cosine squared t plus sine squared t equal 1. Cosine t this time is y. Sine t this time is x. But y squared plus x squared is 1. Exactly same rectangular equation. Both them represent circles with the center is 0 and 0. Radius gonna be 1. But parametric equation represent different circle. One is counterclockwise. The other is clockwise. That's the strength of parametric equation. Let's see. You're going to see 3 different circles here, guys. Look at this. First one is parametric equation. I sketched the curve. You sketch the curve. You're going to start here, going to counterclockwise. So object move, start here, move counterclockwise. That's represent this parametric equation. Second is, that's parametric equation. You start 0 and 1, and clockwise you're going to move. That's the second parametric equation. Third one is a circle. They don't have any direction, any movement. Just the equation of a circle. X squared plus y squared is 1. What is the different? 3 curve. First two is show the direction where they start. Third one is only curve. Also, first two is have the direction. First one is counterclockwise. Second is clockwise. First two graph curve is represented by parametric equation. Third one is rectangular equation. So parametric equation give direction and movement on the curve. Let's have another example about parametric equation. X equals sine t, y equals sine squared t. Let's sketch the graph first, guys, okay? So t gonna be right here. Let's find each position as t is increasing. So let's go to t equals 0. What happened? 0, 0, 0, 0. That's the origin. T equals 0. T equals pi over 2. 1, 1, 1, 1. That's going to there. That's the direction. That's going to that direction, guys. So, next one, pi. Sine pi is 0. Sine square, 0 is 0. 0, 0. So, coming back to origin, guys. Look at this. Coming back this direction. 3 pi over 2. Sine 3 pi over 2, negative 1. Negative 1 square is 1. That's gonna be negative 1 and 1, right? So you're going to this point. Guys, make sense? That direction. Now, t equal 2 pi, sine is 0, sine square, 0. 0, 0, going back to origin. Then, same thing over again. So here, 0, go to 1, go back to 0, 0, go to the negative 1 and 1, come back down 0, 0. That's keep repeated that movement based on this parametric equation. Now, let's find rectangular equation for this parametric equation. So you see, x equals sine t, but sine t is bounded. x equals sine t. Sine t, always minimum is -1, maximum is 1. So x is sine t, right? X gonna be between -1 and 1. Y equals sine square t. What is sine t? That's the x. Y equal x squared. That's what we call rectangular equation. Only x's have value between -1 and 1. That's what we call rectangular equation. This is parametric equation. This time, we want to find parametric equation when you are given rectangular equation. What is rectangular equation? That represent curve by using y and x. So that's what we call rectangular equation. Now we're gonna use parameter to find parameter equation from rectangular equation. So this time, you want to pick the parameter first. This situation, you're going to pick x equal t. Then when you pick the x equal t, y also change a function of t. So y equal 1 minus x squared, x gonna be t. So this gonna be y equal 1 minus t squared. We have parameter equation for rectangular equation y equal 1 minus x squared. Here is x equal t, y equal 1 minus t squared. But when you find the parameter equation, there is not one parameter equation for given rectangular equation. So we're gonna choose another parameter. This time, I'm gonna pick x equal t minus 1. You might thinking about x equal t plus 1, x equal 2t, whatever you're gonna pick, it depends on the question. So if you x equal t minus 1, y gonna be 1 minus square, x is gonna be t minus 1, so you have y equal 1 minus t minus 1 square. So let's simplify t minus 1 square. So 1 minus t square minus 2t plus 1. Distribute the negative. You have negative t square plus 2t. Negative 1, positive 1 is cancelled out. So you have x equal t minus 1, y equal negative t square 2t. Whatever you pick the parameter for the rectangular equation, both parametric equation represent this rectangular equation. This time, this is very important example to find parametric equation for the line passing through 2 points. So idea is here, guys, you have 2 points. P1 is x1, y1. Another one is x2, y2. That's the point P2. Connect the 2 points. Start is P1 and the point P2. So you're gonna draw the line. We wanna find the line from P1 to the P2 by using parametric equation, not the rectangular equation. Rectangular equation is y equal mx plus b. That's the line equation, right? But we're going to use parametric equation to find this, to represent this line. So you only know 2 points. So how going to find it here, guys? T is normally pick the 0 and 1. T0 meaning is initial point, P1. T equal 1 gonna be P2. That's normal way write the T value. How gonna find the X in terms of T? So here is X, here is Y. Parametric equation to represent this curve. X1, that's the initial point, plus T, x2 minus t1. Y gonna be y1, y value of initial point, t, y2 minus y1. So what is this parametric equation represent? T equals 0. T equals 0. When you plug in t equals 0, the meaning is x equal x1, y equal y1. That's represent P1. Start point. T equal 1. You're going to plug in the 1 here. x1 plus t2 minus x1. That's x1 is cancel out. X going to be x2. Y going to be y1 plus y2 minus y1. Y1 is cancel out. You have y2. T equal 1. That's going to be T2. Represent T2. That's the terminal point. This is general way to write the parametric equation for the line passing through the 2 points. So t gonna be 0 and 1. X value gonna be x1 plus t, x2 minus x1, y equal y1 plus t, y2 minus y1. Let's have one example to find parametric equation for the line passing through -2, -1, and 2 and 2. So here is the coordinate plan. Point is -2, -1, 2 and 2. We want to find this line segment by using parametric equation. T value is always 0 and 1 when you're talking about line segment. X gonna be x1 plus t, x2 minus x1. Y gonna be y1 plus t, y2 minus y1. You can change the order. X1, y1 is the initial point. X2, y2 gonna be terminal point. So when you plug in x1 -2, x2 is 2, x1 is -2. y1 gonna be -1, y2 gonna be 2, y1 gonna be -1. So we have x equal -2 plus 2 minus 2, y equal -1 plus t2 minus 1. So 2, negative make positives. You have x equal -2 plus 4t. 2 minus, that's positive. That make 3t. Y gonna be -1 plus 3t. So you have this parametric equation for line segment where t gonna be 0 and 1. Let's check it out. T equals 0 is initial point. T equals 0, you plug in the 0. X gonna be -2, y equal -1. That's the initial point. T equal 1, you plug in the 1. -2 plus 4 is 2. -1 plus 3 is 2. So x, y position gonna be 2 and 2. That's gonna be terminal point. So this parametric equation represents line segment from -2, -1, 2 and 2. What do you learn this session? We learn parametric equation represent curves by expressing both x and y in terms of parameter t. T normally represent time. Second is that parametric equations show how a point moves along a path, revealing direction and orientation. That's different from regular equation for curve. Third one is you can convert between parametric and Gaussian form to connect two representation to familiar shape, such as line, circles.